Are you ready to evaluate some Terraform plans using opa and Rego? Let's get into it. What's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and today we are getting into the next in a series of videos all around Open Policy Agent, or OPA, and how you can use it with Terraform. In a previous video, we looked at how you can generate a Terraform execution plan, convert that execution plan to JSON, since that is what OPA is expecting, and then start examining and peeling back the layers of that execution plan using some helper functions that we wrote in Rego, which is the language that OPA used. So if you haven't checked out that video and you want to get up to speed, you should probably do that first, because we're diving right into the deep end today. Today, we are going to create actual policies that we want to evaluate using those helper functions and some additional ones that I've added into the mix. And then we're going to see how to run OPA at the CLI to query on the different decisions you can encapsulate in your policy and how they might fit into a CI/CD pipeline. That's what we're going to cover today. Before we get into it, I want to thank today's sponsor, M0. M0 is a platform that can help you with your Terraform deployments. It fills in all the gaps that Terraform open source just happens to have. So if that's of interest to you, check out a little bit more about M0 at the break. Okay, let's get right into it. I already have my code editor up, and if you're looking for the files here, it is included down in the description, and it's a repository on GitHub. So I try to make this as easy as possible for you. We're going to be working in the for running opa exec directory today, so I'll go ahead and expand that. And just to refresh your memory a little bit from last time, we have a very basic Terraform configuration that we're using as our jumping off point, our starting point to generate a Terraform plan. Let's just review again what's in that configuration. So looking in the main.tf file, we have an Azure resource group, an Azure virtual network, and subnets being added to that virtual network. So pretty straightforward configuration. We're also adding common tags to each of the resources that supports common tags, in this case, the resource group and the virtual network. Those common tags are coming from a variable. So let's open up our variables.tf. And in here, here's our common tags variable. It has a default that defines an environment and a project. And that's it. We could change this by submitting a different value, but this is pretty good. We'll go with that for now. Now, this virtual network does not currently exist, neither does the resource group. I've run a Terraform plan and sent that Terraform plan to an execution plan file, which is down here under vnet tf plan. Now, of course, you can't look at a tf plan file because it's in binary format. And unfortunately, OPA can't look at it either. So what we need to do is make this a JSON file. And we did that last time, and I did that earlier by using the Terraform show command, feeding it that tf plan file and telling it we want the output in JSON and sending that to vnet.json. So this is the actual JSON data that we're working with. When Terraform generates it, it doesn't put all the nice line breaks in. So if you have VS Code and prettify JSON, you can make it look a little bit nicer just like that. This is the actual data that we're working with. So that's to set the stage for you. The other thing that we were working with last time was a set of Terraform helper functions that we designed inside of a file that was .rego. Now I've moved that file into a policies directory, but those functions are still there. Some of the function that we're working with: get resources by type, get resources by action, get resources by type and action. The idea here is I can pass it the resource changes that are in my plan and tell it filter on some attribute, whether it's the type or what action is happening, and get back a new set of resources that matches that filter. So I can get all resources of type Azure RM subnet that are being created by this plan, and I can do that with the get resources by type and action. Okay, so that covers the bases on what we had done in the previous video. Now let's get into the new and cool stuff. One thing you may have noticed is that the Rego files are no longer living in the same directory as the Terraform configuration. I've moved them into their own policies directory. And now there's more than one .rego file. Before we just had one, and now I've split it up into 3 different files. One of the things you can do with OPA when you run it is you can pass it a directory where all of your Rego files are, and it will add them all to the data portion of the virtual document. Do you remember the virtual document? You might not. When you run OPA, it generates a virtual document where it evaluates the rules against your input data. So that virtual document has a data portion and an input portion. All the rules and policies go in the data portion, and you can take packages from multiple different files and reference them as long as they're all part of that data document, which in our case, they will be. So to increase reusability, I split out the helper functions into their own file. Within the Terraform functions file, a few things have changed. You might notice that there's fewer import statements, and also the functions themselves have changed in a slight way. If we go back to the 3 parsing Terraform plans folder and take a look at the Rego that was in there, in addition to the import command for future keywords, there was also an import of the input.resource changes using resources. And then in the functions, we were directly referencing that collection of resource changes using the keyword resources. When we go to Terraform functions, it no longer has that input data imported directly into this package. So instead, I've added a second argument to each of the functions that represents that collection of resources that will pass to the function along with the type or action. So we've simplified this particular Rego file to only include the package and the future keywords if we want them. Now let's take a look at this other new set of policies, tag validation. And I think you can guess what this one's all about. It's all about validating tags. So the package name for this one is terraform.tag_validation. And once again, I'm importing future keywords. Keywords are things like if, contains, etc. And I've written a few functions here. The first function takes a resource and returns just the tags that exist inside of that resource. If you just want the tags of a resource, you can use that function. And we actually leverage that function directly below in the find tag function. The purpose of this one is to take a resource and a tag name and return true if that tag name exists. The next one is find value. This one looks for a specific tag and tag value in a resource and returns true if it finds it. And then lastly, I have a function here that checks to see if any tags are missing from a list of tags that are required. So it takes a resource and a tag list. And the syntax here is a little bit interesting, so I did want to go over it very briefly. First, we're extracting all the keys from the resource that's passed into it, all the keys for the tags. And then we're doing an operation where we subtract that list of keys from the list of tags that was submitted. If there's anything left, that means there's some required tags that were not in the list of keys, so that we're missing tags. And then we test to see if missing is equal to the empty set. If that tests to true, then there are no missing tags, and this resolves to true. If there are missing tags, then this will resolve to false, and missing tags will resolve to false. So that's how we're getting our test to see if there's any missing required tags. These are all part of the tag validation suite of functions, if we want to call that, but it's really called a package. Okay, now let's move on to the actual policies that we're going to be using, and we're going to leverage the functions that we have in tag validation and Terraform functions. Special thanks to today's sponsor, M0. When you think about what you can do with Terraform open source, it's pretty incredible. You can deploy infrastructure from code in a quick and consistent way. You can create reusable components in the form of modules, and you can store your state in a shared location to collaborate with others. The thing about Terraform open source is there's still a lot for you to manage, and that's where M0 comes in. They've got a private module registry, remote state that supports RBAC, and a customizable workflow for deployments. In fact, that's one of my favorite things about M0. You can define a custom workflow in code and keep it with the rest of your configuration. That's pretty useful. And as part of that customization, you could run OPA commands to test the outcome of policy rules. So if that sounds interesting to you, head on over to m0.com and start a free trial. Tell them Ned sent you. Now back to the video. Okay, let's dig into our policies we actually want to evaluate against our plan, and those are in a file called production policies. Now this has the package production, which says to me, these are the policies I want to apply to a production deployment. But you could have a separate file for development or staging, and you could actually put all of your environment files in their own directory and just submit one of them along with the other helper policies when you invoke OPA. For simplicity's sake, I just kept it all in the same directory. So it's up to you if you want to try to figure that out. It's not too hard. Now, below package production, I've got a few import statements. The first two are what allows us to use the functions that are defined inside the other packages. So we're importing data.terraform.plan functions. Terraform.plan functions is the package name of our Terraform functions. And we're also importing data.terraform.tag validation. Now I have access to both of those functions, and we'll see how we invoke them in a moment. I'm also importing the resource changes that are in the input data that is being submitted so I can reference those resource changes throughout this policy. Below that, we're setting some values that we want to check for. So let's say we want to check for a list of required tags for particular resources, and we also want to make sure we're not exceeding certain maximums in terms of created items, deleted items, and modified or updated items. So I'm defining some values here to check all that information. Below that, we have the use of our functions, our helper functions, to get the number of resources added, removed, and changed. So we're going to use the function getResourcesByAction. And the way that we reference that is first the import statement gives us access to plan functions, and then we just add dot and the function name that exists inside that package, getResourcesByAction, and pass it create in this case, and then the group of resources we want to check for that action against, which is in resource changes, which is from another import statement. So that will return all resources that are being created and put that in a variable called resources added. And then we'll do the same thing for removed and changed, checking for delete and update respectively. Now that we have those sets of resources that have a particular action applied, we can check to see if we've gone over the maximum for that particular action. And so I've defined a policy here called warn with an input variable, or I should say just a variable called MSG, which is short for message. And inside the contents of this, I first have a test. The test is the count of resources added, the number of elements in the resources added greater than the maximum number of allowed additions, which right now is set to 10. If that resolves to true, then it will set the message equal to too many resources added, only X number can be added at a time, and we'll set that %D, which means a number, that's sort of the verbiage here, to max additions. So that should resolve to only 10 resources can be added at a time. And then we'll do something similar, but maybe for deletions, I'm a little more concerned. If I see a lot of deletions, I want to stop this process in its tracks. So instead of a warn message, I now want to create a deny message, deny approval on the deployment of this execution plan. For this one, I'm going to check to see if it's more than the number of max deletions and add that to the MSG, that's the message that's associated with deny. Now, an interesting thing about OPA is if you have the same variable or same rule multiple times, it's additive. It does an OR of it. So I can reference the same warn rule again and add another message on top of it, or add a new message to it. So it will append each message for each warn that I have. So I have another warn rule that's about modifications, just checking to see if there's too many modifications in there. Okay, so that's everything to do with the max and min counts. The next thing I want to check is to see if any of my virtual networks are missing required tags. The first thing I need to do is get a list of my virtual networks, and I can do that using the get resources by type function that's inside of plan functions. So I'll do that and I'll pass it Azure RM virtual network. That's what I want to get, the resource type, and I'll pass it the resource changes that has all of the changing resources. Once I have my list of VNets, I also wrote a function that takes a list of resources to check and then checks to see if there are any missing tags. And the way that it does that is down at towards the bottom of the rule, I have a not keyword followed by tag validation.missing tags, the resource that we want to check, and the required tags that we want to check it against. So we're invoking that function. Remember, if missing tags is true, then there's no missing tags. And if missing tags is false, then there are. So the not there basically says, if there are missing tags, then I want you to populate this resources with the one that's missing the tags. Okay, so that's what tags contain required. Now, finally, we're going to add another deny message because I don't want to deploy this if there's any tags missing. And for the deny message, we're first going to get a list of resources and use our function tags contain required and pass it the VNets. It'll pass it the VNets. It'll run through the logic to see if there's any missing tags. And if there are, it will populate the resources variable inside of here. Then we have a test to see if resources is not empty. If resources is empty, then nothing is missing and we're good. It won't add the message. If there are resources missing tags, in this case VNets missing tags, then we'll add another message to our deny messages that says the following resources are missing required tags. And inside of there, we'll reference the address of that resource so that whoever's working with this can find that particular resource and remediate whatever the problem is. Okay, so those are all of the functions. I know that was a lot to take in, so maybe take a moment to digest it, take a look for yourself, and then we'll move on to how we actually execute against this using the OPA command line tool. Previously, when we were working with OPA, we did OPA run and went into the interactive shell environment. And that was good for testing and checking things out. But in an actual CI/CD pipeline, you might want to not do that. You just want to check and see what the evaluated decision is for a particular policy. So that's what we're going to do now, and we're going to use opa exec to do that. So let me pull up the terminal here, and we're going to run the opa exec command. So the opa exec command starts with opa exec, and it does exactly what it sounds like. It takes a set of policies, some input data, and then it renders out the decision of a particular rule inside of your policies. So first, we need to pass it the policies that we want. We can do a -H to look at all of the arguments that it takes. The one that we're interested in is bundle. So you can set a bundle of files that are a particular directory path that's going to have all of your policies. So let's start with that. We'll do -- bundle, and we'll point it at the policies directory. There we go. That's where all of our Rego files are. It's going to load those as our policies. Next thing that we want to look at is the decision of a particular rule. And the way that the syntax goes for this is the package name, in our case, is going to be production, and then the rule inside that package that you want after a /. So the rule that we care about is deny. That's the one we're going to evaluate first. And then lastly, it needs the input data, and that's stored in vnet.json. I'll go ahead and run that. And the result that it gives back to us is in JSON format, and it lets us know that the result is the following resources are missing required tags, Azure RM Virtual Network main. Okay, now we know that we are in fact missing tags, and we kind of knew that to begin with because the tags we were looking for are environment, project, and owner. And if you remember looking in the variables.tf, we set the default to environment and project. So We know that's missing. Now we can check and see if that goes away very easily by changing it to just project and environment and then running the same command again. And when we do that, the result is blank. So we completely pass on that one. The other thing we could do is check on the warn message. So let's change the decision from deny to warn. When we do that, we get no results because we have fewer than 10 additions and modifications. Let me change the maximum for additions to 2 and just see what happens when I do that. Now we get a result back on the warn that says only 2 resources can be added at a time, and we're adding 4 in our case. So we are going over that limit. Now that's probably too low, but I did just want to check and make sure that the warn was working as well as the deny rule was working. So you can imagine how you might leverage this in a CI/CD pipeline. You could check the results of the warn decision, and if it's just a warning, you might want to allow it to be applied, but first require someone else to authorize the change or authorize what's going on there, some kind of approval process. For the deny message, if that has any result in it, you could check on that and say, okay, if it's deny, then I'm going to stop it in its tracks. You cannot apply this execution plan until you've remediated what's in deny. And you could have a separate rule that's just info. So you just want to provide some information that gets logged somewhere for people's future reference, but you don't want to stop the process in its tracks. So you have a pretty flexible arrangement there, and you can easily plug this into whatever CI/CD pipeline you're using by just invoking opa through a bash script or something along those lines and parsing that JSON. Okay, that's going to do it for today's video. In the next video, I'm going to take everything that we've done here, and we're actually going to put it into a CI/CD pipeline. I'm going to be leveraging M0 to do that, so stay tuned for that video. Thank you so much for watching today's video. If you don't mind liking and subscribing, I sincerely appreciate it, and I will check you next time. Till then, stay healthy, stay safe out there. Bye for now. So if you also happen to work with Vault, and I know some of you do, there's a new book out. It's called The Best Kept Secrets of HashiCorp Vault, and I am one of the contributors to it. So it was a community-focused book, and it's a collection of practical tips from the HashiCorp community. There's a bunch of contributors on it, and all proceeds are going to charity. So if that's of interest to you, a link is down in the description to purchase your copy on Amazon. Thanks, everybody. Bye.